I extend a warm welcome to Mr. Dan Schrag to kindly deliver his keynote address on climate projections, the known threats of climate change, and India's role in global solutions. Mr. Schrag is the Sturgis Hooper Professor of Geology at Harvard University, Professor of Environmental Science and Engineering, and Professor of Public Policy. He studies climate and climate change over the broadest range of Earth's history. Please welcome, can we have a round of applause for our esteemed dignitaries and for Mr. Dan Schrag, who is about to deliver the next address.
Good afternoon to those of you who are here to talk about climate change. So, the world has a big problem, and it's time to prepare. For far too long, many of us in the climate community have neglected what we call climate adaptation, really preparing, what I call preparedness, preparing for what is coming. India, both because of its capabilities and because of its vulnerabilities, has in some ways a special opportunity to lead the world in thinking about how to prepare for climate change. It's a universal requirement for all countries, but India can play a special role, and that's what I want to talk about today. I have to start with the nature of the problem. I'm a climate scientist, and so starting with carbon dioxide rising in the atmosphere is a basic requirement. As of yesterday, the CO2 in the atmosphere was 427 parts per million. Kind of extraordinary for me. When I was in graduate school, I learned that it was 350 parts per million. It has gone up more in my career than it has from the pre-industrial period in the 1850s all the way up until the late 1980s. That's not a good sign. I'm a geologist, and I think about carbon dioxide not just rising from when Dave Keeling started measuring it in Mauna Loa, 315 parts per million, all the way up till today. But I think about it more like this. This is an 800,000 year record of carbon dioxide in the atmosphere. It attaches the ice core record of CO2 in the Earth's past to the Keeling curve, which you see is basically a vertical line on the right. CO2 today is so much higher than we've ever seen. No human has ever seen carbon dioxide levels until the industrial period above 300 parts per million. And now it's 427 and still rising quickly. I'm not going to talk about exactly what this is going to mean, and I'm not going to talk about reducing emissions, even though that's something I'm passionate about and I work on. We're going to talk about adaptation today, but it's important to still mention that solving climate is a collective action problem, and it's global. We heard Sri Berry earlier mention the fundamental issue of climate justice. I actually don't like the term climate justice because to me, the injustice of climate change is so profound. I prefer the term climate injustice. This is a chart showing cumulative emissions, which is what really controls the response of the atmosphere to human activities, because carbon dioxide has a very long lifetime in the atmosphere. What you can see is that I come from a country that has contributed roughly a quarter of the cumulative contribution of carbon dioxide to the atmosphere. India, a mere 3.3%, but has more than 4 times the population. I'm not going to fix that injustice, and we can zoom in on this so you can see all of the other countries in Asia and the tiny proportion of greenhouse gases they've contributed. So climate change is fundamentally unfair, and I feel as an American I have to say that. At the same time, I think there's a lot that we can do to help the people most affected by climate change, even though they didn't actually contribute to the problem. I also emphasize that we have a generational responsibility. We're making decisions today that will affect the freedoms and opportunities for thousands of generations of humans. And that's because the other problem of climate change is that the timescales are so long. The Earth is likely to keep warming for centuries, even with intense efforts to reduce emissions. And that means impacts of climate change are going to continue to intensify for centuries and millennia. This is a very long timescale problem, and unfortunately, humans are not good at thinking about long timescales. So let's jump in and talk about what is going to happen. These are projections of various scenarios for fossil fuel emissions in the future. The biggest uncertainty in what is going to happen with our climate is what are we going to do to the climate in terms of carbon dioxide emissions. The IPCC uses these scenarios. You can think of them as very low, low, medium, high, and very high. What the IPCC doesn't often like to say is, where are we in terms of the likelihood of following each one of these? I'll give you my opinion. The two bottom ones are absolutely impossible. Today, we are somewhere between the yellow and the red, and I fear we are, unfortunately, more likely to head towards the red than the yellow. What this means, if we translate this through climate models into forecasts of how global average temperature will rise in the future, we're talking about, in the yellow, maybe 2 degrees of warming by the end of the century. In the red, maybe 2.5 to 3 degrees of warming by the end of the century. But let me point out, that's warming relative to 1995 to 2014. That's not pre-industrial. So what we're talking about really is 3 to maybe 4.5 degrees by the end of the century. That's where we're heading. The big question is, what does this mean for what we experience? Nobody here experiences global average temperature change. So what does that really mean? And that's where the work gets difficult. I want to first show this figure. This is the spatial pattern of temperature change in 2024, the annual average temperature, relative to a deviation from a 1951 to 1980 baseline. This is from NASA. It's a spectacular image. The temperature scale is on the left. The red is 2 degrees above that baseline, that mid-20th century baseline. And I hope everybody can see something really clear, which is the continents are warming much faster than the oceans. This is exactly what we expect from the basic physics of climate change. And the reason is very simple. The oceans mix, and so they actually take up heat. Indeed, 90% of the energy imbalance caused by putting greenhouse gases in the atmosphere is taken up by ocean heat uptake. So the oceans are like a giant air conditioner. If the whole Earth were covered with land and not ocean, the Earth would have warmed much, much faster by now. That's good news and bad news. The good news is the Earth hasn't warmed as quickly. The bad news is there's a lot more warming built into the system that's still to come, because the oceans will continue to warm for centuries until it's achieved a new radiative balance. Let's talk about what this kind of warming on the planet actually means for the weather we experience. And we could talk about so many different impacts. We could talk about sea level rise or extreme precipitation, droughts. For today, because my time is so limited, we're going to just talk about heat waves. And I want to talk about a few examples. This was an extreme heat wave in Western Europe in 2003. 70,000 people died by estimates of excess mortality. More than 15,000 people in France, where you see all of that red area, which is between 5 and 10 degrees Celsius above the average. This was an incredible heat wave with incredible mortality. This is my colleague Dave Battisti from University of Washington, who's here joining us in Delhi this week. He wrote this paper in 2009 really about food insecurity. But I want to show you this picture here. What this shows in the blue is the data from 1900 to 2006. 2003 is that extreme point that's about 3.5 degrees above normal. That would be averaged for the whole summer. So it's not just the heat wave, but averaged over the whole summer. And in the red, what you see is a model result. And notice models produce a nice smooth curve. The real data aren't actually that smooth. That's one of the challenges with models. But what you see, and I think one of the main points, takeaways from this paper, is that by the end of the century, the average summer in Western Europe, in France in this case, would be equivalent to that 2003 extreme heat wave. This is the challenge ahead for climate adaptation. We have to prepare for something that nobody here has ever seen. By the way, in 2022, there was another heat wave in Europe, and the temperature was even higher. So things are not slowing down. So let's go back to this NASA image of 2024 temperature and take a look at South Asia, take a look at India and the subcontinent. It's kind of interesting. India is one of the places in the world that has warmed substantially less than the global average on continents, on land. It's about half the warming that the rest of the world has seen since mid-century. The reasons for that are a little complicated. We think there are two main factors. One is aerosols, essentially pollution that is reflecting some sunlight and actually preventing some of the warming. And another factor is the massive irrigation across the agricultural lands of India that are actually increasing soil moisture and increasing evaporation, which is reducing the temperature. And those are some of the things that we'll be talking about over the next several days. Again, this reduced warming is both good and bad. It's good that India hasn't yet experienced what some places in the world are experiencing now, but it's bad because that warming will come. Both because the irrigation and the soil moisture is not likely to be able to be sustained, and also because India does need to clean up its aerosols for all sorts of other health reasons. The consequence of that means that India is probably going to warm faster over the next 20 to 40 years than the rest of the world, and that's a little bit concerning. In terms of heat waves, I don't need to tell people here what that feels like. Here is an article from 2020. Delhi temperature hits 47 Celsius as North India reels. This is from the BBC. Here's another one from 2022, where a nice analysis of climate change suggested that it would make that warming over the last century made heat waves maybe 30 times more likely than otherwise to occur. A recent figure by Lucas Zapatello at Berkeley and Aditya Pillai, who's sitting right here. Lucas and Aditya are in some ways already collaborating across our countries on this topic. And what this figure shows is the percentage increase in the heat index in India, the extreme heat index, for across India for 1.5 degrees, which is essentially where we are today. This is relative to 1.2 degrees. Essentially, what this is showing is how much more likely are heat waves, extreme heat waves today relative to what they were maybe 20 or 30 years ago, when we were only 1.2 degrees warmer. And what you can see is the answers is a lot. In northern India, 18 to 20% more likely to have extreme heat waves today than just 20 years ago. And I can tell you that the difference between today and 2047 is likely to be much more than this. So this problem is getting worse. It's getting worse faster. I also think it's important to remember the timescales of climate change. That is, this problem isn't going away. Yes, adaptation is critical and we've neglected it, but if we don't fundamentally fix the problem, if we don't actually reduce global emissions, and that is a global responsibility, then adaptation becomes almost impossible because the climate keeps warming. So let's talk about some of these heat waves. It's an important thing, and I just want to end on this comment here. We often think of heat waves as well, how much more likely are they going to happen, a figure like this? But there are absolute limits. And one of my colleagues here who came all the way from Australia via Germany, Steve Sherwood, who's at University of New South Wales in Sydney, Australia. Many years ago, 16 years ago, he wrote this paper with Matthew Huber. This was a very influential paper because it introduced the idea that there are actually absolute physical limits to human viability in the intensification of heat waves. Essentially, what this paper talked about was the idea of a wet bulb temperature. A wet bulb temperature is a way of combining temperature and humidity. And above a wet bulb temperature of about 35 degrees Celsius, when the body can no longer cool itself, either by evaporation or by radiation of heat away from the body, above a wet bulb temperature of 35 degrees Celsius, it doesn't matter whether you're indoors, it doesn't matter whether you're resting quietly on your bed, above that temperature, it will be fatal. I think until Steve wrote this paper, I think many of us didn't think about climate change quite in that way. We thought it was going to get worse and worse and we would have to be creative about adaptation, but we didn't think about the fact that in some parts of the world, these limits may actually get reached. So another way to say this is just that combining heat and humidity, it really sets an absolute limit to human survival without access to cooling. This, in some ways, is fantastical. It seems appropriate for science fiction, and indeed, soon afterwards, Kim Stanley Robinson wrote this novel, The Ministry for the Future. This quote here from Jonathan Lethem says, "The best science fiction, nonfiction novel I've ever read." Well, I think that's not quite fair. It's still science fiction. But the question is, will it be science fiction 50 years from now or 70 years from now? The book starts out with a series of chapters describing a heat wave here in India that kills 20 million people. Hard to imagine. And yet, that in some ways is what we face, not just here, but other parts of the world as well. But this may be one of the early places where it starts. So how do we deal with this? This is the work ahead, and I want to make this very clear. From all over the world, from across the US and Canada, Australia, Europe, my colleagues and I are coming here to work with Indian scholars, and we have questions. We don't have answers. My hope is that over the next several days, we will work together, asking those questions together, and come up with a research agenda that we can collectively pursue over the next several years, to the point where if we came back here a few years from now, we would start to have some answers together. These are hard problems. Let me give you some examples. From climate and agricultural scientists, how does the change in the average temperature affect the peak temperature experienced during a heat wave? To put it simply, if India warms by half a degree out to 2047, how much warmer do heat waves get? What's the peak temperature in Delhi? Does it also warm just by half a degree, or does it warm more than that? The answer today, we don't really know. Can we predict the intensity of heat waves to better allow societies to prepare? My colleague Bill Boos at Berkeley is here in the audience, and he's done some work suggesting that may be possible, but we need to think about this because it's urgent and important. How will heat waves affect agricultural yields and water demand? There are many people here in the audience who've thought about that, and we'll be talking about that over the coming days. And of course, there are many other questions related to food systems and many other aspects of agricultural productivity. From health scientists, how is mortality affected by extreme heat? Are there interventions, and how does the medical community provide care? From social scientists and policy scholars, how can we adjust people's work conditions to prepare for heat waves in the future? What kind of policies are most effective in protecting our communities? And then finally, from architects and engineers, How do we change the built environment to reduce vulnerability and create shelters for people as the climate warms? And how can we scale solutions to be effective for 2 billion people, not just in India, but across South Asia? These are colossal challenges. And I think the reason many of us have come from so far to be here this week is because we see really an opportunity and an obligation to come work together and try to tackle this. These changes are coming. We are not going to just stop them in their tracks. And so the question is, how can we prepare for what's ahead? Thank you very much.
Thank you, sir. That was indeed an extensive and informative address.